Hi students, welcome back to this course again. An introduction to mechanical engineering. I am Professor Yao. Case study 3, jet engines. The history of jet engine. The keywords. The final application of thermal and energy systems. The jet engine. Downstream of the combustion chamber. The engine's compressor. Jet aircraft propulsion. The history of jet engine. The final application of thermal and energy system that we will consider in this chapter is the jet engine, which was invented by Frank Whittle as earlier as 1929. The first flight of an experimental jet aircraft in England didn't take place until 1941. Whittle's contribution was the idea to insert a turbine downstream of their combustion chamber so that the turbine could drive the engine compressor. In doing so, the engine could be made lighter and more powerful. A parallel effort had been underway in Germany by an engineering student named Hans von Ohain, who was only 22 years old when he began to develop his ideas for jet aircraft propulsion. Turbojet and the turbofan engines. The keywords. Turbojet and the turbofan engine. Gas turbine. Remarkable mechanical engineering achievement. Forward thrust. A module. Advanced jet engine. Near the center of the engine. The compressed fuel-air mixture. Expand. Forward thrust. Turbojet and the turbofan engine. Essentially a long-haul commercial aircraft flights are today powered by turbojet or turbofan engines with different paths of airflow. Similar systems called gas turbines are used to produce electrical power and to drive ships, military tanks, and other large vehicles. Jet engine designed for power, thrust, low weight material selection, fuel economy, safety, and reliability is remarkable mechanical engineering achievements. Layout for two main types of jet engine are compared in Figure 7.25. In a turbojet engine, air is drawn into the engine front, is compressed. As fuel added to it is ignited and burned, and then it expands and exhausts through the nozzle located at the back of the engine. The high velocity of gas as it exists, The nozzle provides the aircraft with forward thrust. The sequence of stages occur in a module called the engine core, the internal construction of which is shown in figure 7.26. The turbofan engine is also formed around the core, but it further incorporates large fan blade that core directly driven by the engine. While some fraction of thrust is provided by the exhaust gas, as it exists, the nozzle, the fan provides a significant amount of additional thrust. Some advanced jet engines use fan blades that are made from lightweight composite material. A schematic of jet engine's internal construction is shown in figure 7.26. Air enters the front of the engine and is compressed in multiple stages. The compressor is powered by the shaft that extends down the engine's center line back to the turbine. Near the center of the engine, the compressed fuel-air mixture is ignited and burns in the combustion chamber. The high pressure and high temperature gas expands and drives rotating of the turbine. The turbine is similar in appearance to fan, and the compressed main short blades. The shaft that provides power to the compressor extends forward from the turbine along the length of the engine. The turbine produces just enough power to drive the compressor, and the energy remaining in the combustion gas provides the plane with its forward thrust. Homework: handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz, and see you next time.